Welcome to Study Loop.
Okay, so the problem must have a typo. If you see the spacing between each point is 0.4, and they go from 1.4 to 1.6 in the last one. So that last one should be 1.8 right here. This tick mark should be 1.8, not 1.6. So we see that the period is 1.6 because at t equals 0, we start, and then at 1.6 we return. Okay, so t equals 1.6 seconds. The frequency is just the inverse of the period, which equals 0.625 hertz. The angular frequency equals 2 pi over t, which equals 3.925 radians per second. All right, we know that that the system is, so basically that the max speed Vmax will equal A omega. Well, Vmax is 0.2 equals A times omega, which is 3.925. This implies that A equals 0.05 meters. Acceleration. So we reach maximum acceleration. A omega squared. So we reach maximum acceleration at A omega squared, which in this case equals 0.78. So if we just solve for A, and we know what omega is, this is meters per second squared. And it occurs at the extreme positions, basically where the velocity is 0, but the slope of the velocity, so like a point like here, where the velocity is 0, but the slope of the velocity is greatest. And then finally, F, we can rearrange the equation for so the period is 2 pi m over k. We can rearrange this to solve for m. M equals t squared over 4 pi squared k squared, and k was given in the problem to be 75. So I'm going to write this up here. K newtons per meter. So then if we plug all that information in, we get m equals 4.86 kilograms.